Okay, hello and welcome to our first panel discussion. This is bringing out the data scientist in the decision analyst. My name is Brad Powley, and I will be your moderator for this session, as well as the following session, which is called Bringing Out the Decision Analyst in the Data Scientist. So they're swapped. The title of both of these sessions immediately for me invokes a how question. In other words, how would you bring out the data scientist in the decision analyst? But as I thought about it more, it really quickly gave way to more of a why question, which is, well, why should a decision analyst care to have his or her inner data scientist evoked? And so we're going to address some of those why questions by talking about where the intersection of these two fields are now, and then prognosticate a bit as to where we think they're going. Okay, so that'll address the why. And then given where we are and where we think we're going, we'll get into the how question as the group will give its recommendation, or each panelist will give his recommendation as to, okay, so given our current world, what does it mean for me? What sorts of decisions might it inform for me? Inevitably, these two discussions will overlap. I will do my best to kind of keep them separated, but I'm not super worried about overlaps in the two sessions so long as the discussion is compelling and the recommendations are useful to you all. Okay, so now I guess it's time to meet our panel. Starting with Dr. Dennis Beattie. He's a founder and chief innovation officer at Innovative Decisions Incorporated. He was a professor at Stevens Institute of Technology and George Mason University, and has authored or co-authored numerous professional books and papers. He is a practicing decision analyst, Bayesian probabilist, and data scientist. He received his PhD from the Engineering Economic Systems Department of Stanford University. Welcome, Dennis. Next is Dr. Stephen Malik. Stephen leads True Value Labs' quantitative research team in applying artificial intelligence and machine learning techniques to create new financial signals from unstructured data. He has an extensive track record for successful predictive models using widely varying techniques across numerous domains. He also has significant experience as a practicing decision analyst. Stephen also got his PhD from the Engineering Economic Systems Department from Stanford University, where he studied DA under Ron Howard. Welcome, Stephen. Next is Dr. David Blum. David is the principal data scientist at Next Tier Concepts, where he supports the US intelligence community as a principal investigator in the area of machine learning and data-driven decision analytics. He's also a lecturer at Johns Hopkins University in their Applied Economics program, where he teaches a course called Real Risk. David has more than 15 years' experience performing operations research, decision and risk analysis for the US national security community. He received his doctorate from Stanford University in Management Science and Engineering, which is what the Engineering Economic Systems Department became. You're starting to see a pattern here, I suppose, with a focus on decision and risk analysis. Okay, and welcome, David. And finally, we have Isaac Faber, and just to add a little diversity in the group, he is a PhD candidate in the Management Science and Engineering Department with a focus on decision analysis. He practiced DA as a, his research focus, is applying machine learning techniques to warning systems in cybersecurity. Before coming to Stanford, Isaac was the lead data scientist at Army Cyber Command, where he worked closely with the intelligence agencies like the NSA. He was the architect of the largest operational big data system in the Department of Defense. And he's also the co-founder and chief data scientist of Matrix DS, which is a collaboration platform for data scientists. Welcome, Isaac. And then finally, I'll briefly introduce myself. I, like 3 and soon to be 4 of these people, got my PhD from the Management Science and Engineering Department at Stanford University. with a focus on decision analysis. I practice DA as a strategy consultant and educator at SDG. I'm now part of a team of data scientists at Salesforce. And our group derives insights from customer activity like emails and meetings. And so this has me keenly interested in the intersection of these two fields. Okay, so let's get to the discussion. And I think I'll start with Stephen. What are the challenges that decision analysis organizations face in order to leverage and apply data science?
Well, one thing you want to be aware, we heard earlier today, wouldn't it be great if decision analysis were embedded in our everyday lives? Guess what data science is already? This group is outnumbered by the hundreds or thousands or maybe more than that to one by data scientists. Everything on your phone, everything that comes at you all day long has got little bots in it that are making decisions for you or about you. And wouldn't it be great if decision analysts were more involved in what's going on and thinking about solving the right problems and so forth? So there's just this huge technology, explosive growth that makes certain things possible that weren't really possible 25 years ago.
Thanks. So what sorts of challenges does the group see in applying data science to an organization that hasn't done it before? Yeah, how about you, Dave?
Data science or decision analysis?
Data science.
Data science. Okay, well, so my experience is with the national security community, and although there's a single gigantic organization, the Department of Defense, in reality there's a gazillion little offices that get their funding from one big pot of money, but ultimately do things individually. So I've had the privilege of supporting some organizations that were extremely technically adept and had decision scientists on staff and were doing, had a practice going. And I've supported some that were really just getting off the ground. So the challenges, I think, they're challenges that decision analysts are familiar with. There's a framing problem that is way too easy to jump ahead of. A lot of times, one of these organizations will be directed either in law or ordered by some general above them, accomplish this. And regardless of the source of the direction, the answer is yes, sir, and I'll have it done tomorrow or the day after, or whatever it is. And so they just want to rush to the end and jump ahead of the framing problem. And data science, to some degree, is an enabler in that, in a bad way, right? Enabler like drugs or something. It's you've got these tools that allow you to click a button and run a regression on your data or whatever it is without knowing what it is that you're actually looking at. So the decision analyst can say, hold on, stop, take a deep breath, let's frame the problem, let's figure out what an appropriate loss function is to optimize in our data science in whatever algorithm we're going to be developing to accomplish this purpose that we've been directed to accomplish.
All right, thanks. Dennis, can you give an example of the use of data science in a DA project? And was it successful? Did it fail? And what were your observations?
Well, I'd say in general it's ongoing. The one example is in the intelligence community. We've been working with a customer for quite a while who's very interested in thinking about what the next best thing is to collect. One of the big problems in that context is there are lots of decision makers waiting for that same piece of information, doing for different decisions. So it's very hard to isolate to a common decision. There's been a movement recently toward activity modeling, which is beginning then to say there's a process going on and we want to collect information about that process. And now we're getting closer to aligning what the objective of the customer is to the data science applications to the decision analysis project. Another recent example was we had a large research project within the intelligence community that was predicated upon a decision analysis problem. The decision analysis problem was if you couldn't get anonymized data related to insider threat behaviors, but could get aggregated data, could you use that aggregated data, means, standard deviations, correlations, in a data science context to produce calibrated, precise answers to a decision problem that related to how could we improve, would improvement A, B, or C be the best improvement to the insider threat monitoring system? And we've been able to demonstrate that, yes, that is a possibility. You can definitely create calibrated, precise estimates for that.
Okay, great. So I guess I'll start with Isaac on this one, and you guys can chime in if you like. What are the blind spots within decision analysis when it comes to data science?
Yeah, so I think that we covered this like pretty well a couple days ago when we were doing our workshop on data science. So for anybody that participated, this may be a bit redundant. And I think it was just alluded to here a second ago, is that in the decision analysis community, we don't realize how ubiquitous data and data-driven decisions have become in both the government and the commercial setting. And a lot of the problems that we would champion and that we would consider are in our realm are now being claimed in the data science and artificial intelligence community. So 3 decades of experience on a complex decision. Now you have a 25-year-old graduate student showing up and saying, I can solve that same problem, at a fraction of the cost with this, 3 lines of Python code. And if we don't realize that that's what we're up against, and that we have to make the case that there isn't as much value in that type of quick turn approach, like the stuff that we saw this morning with the keynote speaker, that if you don't frame your problem correctly, and if it isn't, if your solution isn't nested within a larger business process or driven to value for a given organization, that it won't be as useful. And what we've seen, at least in the data science community already, is that the big first wave of business intelligence, which was everybody aggregated their data and put it in one central lake, and then you sat a business intelligence dashboarding tool on top of it, whether it's Power BI or Tableau, and that's where about 2/3 of the industry is right now. And most organizations just aren't realizing a lot of value from that. And so sort of like answering that question from 2 different prongs is that we know why they're not receiving value from that. It's because they haven't answered fundamental questions about value of information, right? What are the questions that we should answer that will provide the most value? However, in order to get to billion-dollar valuations, the data science community has pushed forward in getting these tools out to organizations. And we should realize that that's what we're up against, that the Excel models that we build right now are being compared to beautiful Tableau dashboards. And if you're a consumer of information, it's very clear the vote has been beautiful dashboards.
Any other feelings on the blind spots? I want to give people a chance. All right.
Well, I mean, it goes both ways, too. So the secret weapon the decision analysts have is that they can understand what are the blind spots and what the data scientists are doing, especially if you're working in a field that's changing continuously. So I'm working in financial markets. Every day is different. Gravity flips its sign from one day to the next. It doesn't behave like 98% signal-to-noise ratio. It's more like 0.01 signal-to-noise ratio. And people will take a set of data and make conclusions about it that don't make any sense when something has changed, like a law has been passed, or, oh, we're in a crisis situation, or something different. And that's very natural to decision analysts. They know exactly what to do when the model breaks and can come in and kind of rescue the system, or better yet, prepare it so it doesn't need to be rescued as often.
Good. Dave, I have another question for you. What types of decisions lend themselves to a DA approach, and which types of decisions are maybe better suited for kind of a pure data science approach?
So within the national security world, you'll find decisions that are where there's some decisions where there's both time and money, time available and tons of money at stake. So this might be through the annual budgeting cycle, where a lot more than just what to spend money on is decided, but also where to put things and how to build training cycles for personnel and how to build logistics pipelines to get material. If we're buying aircraft, we're not just buying a plane, we're buying the plane and all the tail that goes with it. So these, are billion-dollar decisions. In the case of one infamous case, a trillion-dollar decision, and it is a question that deserves every decision analyst that the department can spare needs to be put on these kinds of problems. On the other extreme, we have also very important problems, but problems that are repeated frequently, and we don't have the time available to go through the full process for each one because of the speed at which these problems are being faced. And so for where speed is of a greater consideration, we need to be prepared to, a decision analyst approach could be to design a policy that we can optimize, and then we just solve for the particulars of that decision based upon the optimal policy, or it also would lend itself to a more data science approach where you would have a decision analytic, a decision support system that takes data in, makes the appropriate optimization, spits out the decision, and that gets reviewed by a human before being acted on.
So I hear two distinctions here. One is kind of the scale of the decision you were talking about with the first one. The second one is sort of the repeatability or the automatability of it. Are those the only two distinctions that matter? Are those the two things that really kind of separate the two approaches, would you say?
So yes, the speed and the speed certainly. Whether something can be automated doesn't necessarily mean it ought to be automated. I mean, we could probably automate those first class of decisions. We could design a machine that could automatically decide how many F-35s we need at each Air Force base around the country. Doesn't mean that we'd all be happy with how the machine made its decisions.
Right.
So I don't know that the automatability is the basis on which to separate the two, but speed is a huge factor there, and the speed is usually dictated by externalities.
Can I,
Isaac? Yeah, please jump in.
add a little bit to that? So that was a fantastic answer. I would say that if we see the evolution of the answer to that question going forward, there's many settings where you're making repeated decisions, but the impact or the scale of that decision is different based on the temporal aspect of when the decision is made. I can give you an example. So in my research, I do cybersecurity, and the idea is that you have these repeated decisions as to who you're going to let onto your network and who you're not, and at what scale. And sometimes the answer to those questions is very straightforward. You can, very high confidence through even basic data science techniques, say these things should not be on the network. And so you can let a machine make that decision, no problem. However, you start to reach this gray area when you're not as comfortable letting the machine say, well, we probably shouldn't block all traffic from an entire country or an entire continent. Even though the machine thinks it's a good idea, we should hand that off to a human who would be better at contextualizing that sort of information. You can also think about, and we see this in social media right now. So if you're a major social media company and your job is to keep fake news off of your social media site, a good chunk of that can be automated right now, and is, right? So if you go to Facebook, go to, you name it, Twitter, LinkedIn, whatever the case is, they have algorithms that probably are okay automating shutting down many types of posts without it ever passing in front of a human. Excellent data science, artificial intelligence application. However, there still is a team of people, right, expert decision makers, that get handed ambiguous decisions. Should we shut this account down? Well, this probably isn't a bot, but maybe it is a political activist. And if we shut them down, the impact, even though the decision is the same, right, the impact for this one particular decision in a specific context would lend itself more to understanding it through decision analysis concepts than pure data science algorithms. That paradox, I think, is going to drive the future of data science and complementing in decision analysis. So cooperative decision making.
Yeah. All right. Thanks. So you sort of already began to kind of talk about like as we look forward. So let's kind of shift from like what we see now to where things are going. Stephen, how do you see the field of DA evolving with more and better data availability?
I see DA has an opportunity to fix a lot of the problems that more and better data availability is going to give us. The data science is a lot like the old optimization stuff that we used to study decades ago, that, if the terrain is well laid out, you can figure out where you want to go and where the local peaks are. But if it's changing, if there's volcanoes going off and there's bridges out and your self-driving car has come up to an accident, needs to go off the road and do something else, this is where a lot of these systems are going to go wrong. And so the decision analysts can help these people figure out what is not in your sample. And again, going to financial markets, each crisis is different from the previous one. You talk about generals fighting the last wars, technologies, changes. People, it's very hard to see what's coming next, and you need to build these safeguards into the system. And people are very well trained at framing and thinking about possibilities that didn't even exist before, and creativity and things like that can get a lot more robustness into these systems and stop them from doing dumb things like the bot turns someone's account off because there's two acronyms that mean the same thing, and one is illegal and one is completely fine. And people's livelihoods get shut off by some bot with no human intervention. These things can't just be controlling all of these situations all of the time. There's a lot of new things that come up that are unexpected.
So a decision analyst or this decision mindset kind of brings this notion of context or systems thinking to these kinds of problems. Okay. All right, good. I find it really interesting to think about, in the data science community, like data is king, right? Like it's unimpeachable to say we're making a data-driven decision. That's the thing that you'd think of. In the decision analyst community, especially from the early days, a lot of the information that would go into our models would come from expert judgment. And so I find these two ways of getting information to be particularly interesting. And I wanted to pose a question to Dennis. As we move forward in time, as data become more available, what will the role of the expert be with respect to data and using data to drive decisions?
Okay, thanks. And I think expertise is going to continue to be required I believe expertise is going to continue to be required. As several of us have talked about, data sets are generally biased. There's no perfect data set. And without sufficient expertise, you won't totally understand the ways in which the data set is biased. And experts can help us create statistical approaches to adjust the bias so that it's less biased. It's like risk. We'll never get rid of the bias, but we can reduce it. Another characteristic of data sets is that they're often not complete. And we found in a number of cases that when we're trying to build a DA back end, it's often the data that is needed to feed the decision analysis activity that's not there or not complete. And we've relied then on experts to bridge the gap between the data that is available and the extra data that's needed to feed the decision analysis. And in this context, I'd like to make the case that ultimately we need to see decision analysis be part of AI. I was at an AI conference a few weeks ago, and some recognized experts said the biggest weakness in AI is the decision logic, and showed a chart that showed decision sciences as one of a few approaches that are relatively unexplored in the AI community providing that decision logic. And I would argue that unless an AI system has a value function in it, I don't really want it making irrevocable decisions that are going to affect me. And currently, in the deep learning world and other parts of AI, there are no value functions to guide the system.
So
Dave, you have an interesting perspective on this too.
I made a comment earlier in the, I said something about, having data scientists focusing on designing an appropriate loss functions. And I was trying to get at the point that you're making here, that, that these aren't, we don't just have to accept an arbitrary loss function about, how far apart some target is from some prediction. There can actually, we have the freedom to design something that contains value logic in it.
Thanks, guys. So with a little bit of a pivot, I want to talk a little about the data science toolkit. I want to go back to Isaac for this. Will it become more or less important over time? And you would think, well, how could it become less important? For example, like, could it be automated away, for example? So just talk a little bit about where you see the data science toolkit moving in terms of importance.
Yeah, it's a great question. So the toolkit inside of data science has evolved in a couple different settings, depending on what the role of the data scientist is inside of the organization. But we really quickly watched two populations of toolkits come out of, one, the statistics world, and another one come out of the computer science world. And both of them are scripting languages, and they hold sway right now inside of the community. If you apply for a data science job, you'll be expected to either know R or Python. It will be a requirement, or in some cases, both. And it's one thing to just say, hey, these are tools, and they implement specific philosophical logic. But the fact is that the tools are opinionated, and they drive certain types of capabilities. They drive deployment. They drive integration into business processes. So depending on which tool set that you pick, I was just having this conversation with somebody before the session. Depending on which tool set you pick, it will be more or less difficult to integrate decision analysis philosophy into the solutions that are getting in front of decision makers. So I think the tool set is going to continue to grow. As a matter of fact, it's like at this breakneck pace. Like last night, I was doing my daily LinkedIn post, which is like your data science vitamin for the day, so everybody knows what's going on. There's another conference that's happening right now, a Dev Summit for machine learning, and Google just announced the release of their newest version of their deep learning library, deep learning library called TensorFlow. TensorFlow 2.0 just came out, and the whole point of this 2.0 version is to make it easier to use. So not only is the tool set not going to fade away, this is going to be the thing that will be competitive going forward. So I think that it's going to be a requirement for, if you're a decision analyst, you're going to need to pick up some of these tools, or at least know where they're at, understand where they fit into your process, and it will be an expectation. Anybody that you hire that will be coming out of a quantitative field will have exposure to them, and will probably prefer to use them as opposed to maybe some of the more traditional tooling that we've used that come from the business realm. I'm thinking things like spreadsheets. Mm-hmm. So. Yeah, I think the tool set will continue to become more important. I think web applications and web deployed products that get sent to decision makers will become, and I think are for the most part, the de facto tools that people will prefer to consume, and those will be the result of scripting languages.
Mm-hmm. Okay, thanks. Dave, do you think, as you look into the future, will decision analysts become data scientists, or will they work with data scientists, or how do you see this?
So I'm a big fan of working in cross-functional teams, right? I've had good success in my professional career working in teams of 4 to 6 where people bring complementary skill sets. And I would love it if we had the opportunity to have teams with data scientists and decision analysts, as well as potentially, if we're talking a national security problem set, an intelligence analyst, and whatever else the appropriate skills are. That said, realistically, first of all, the decision analysis community has as one of its objectives to help everybody make better decisions, and that should include data scientists, right? I would like to see data scientists become better trained in decision analysis. And then just strictly, being realistic in terms of business, and it's not always that you have that opportunity to bring together people who have deep skills in their respective fields. We need to be prepared to go broad rather than go deep, and that would mean having decision analysts become more comfortable in a data science-oriented world where you are surrounded by data and by bots that are making decisions about you that Stephen was talking about, or vice versa. So I think from prognosticating, it's that the two will become one, not that we'll be able to construct teams that include everybody.
Okay, thanks. So let's get on to recommendations. So given what we've heard, what should the modern decision analyst learn in order to remain relevant in the future? Okay, that's one question. How should they go about learning it? That's another one. And what should they be requesting from their organizations in order to get training? And so I'll pose this question to all of you. I'd like to start with Dennis first.
Thanks. Well, I'm a big believer in learning the basics of scientific approaches to things, and so I would want to start by instead of starting with the R code and the Python, learning the basic underpinnings of what these things are and how they do what they do. The intriguing thing about all of data science right now is they are producing probabilities. And so probability has gone from the scourge back in the 80s when the medical community was working on expert systems and rejected probability to something that's been adopted almost worldwide. And so how do these techniques produce probabilities? And for those of you that haven't delved into Bayesian networks, I would suggest that might be a first step, because there we're dealing explicitly with probabilities. We're not computing them from some ensemble models or deep learning algorithms and so forth. But ultimately, a lot of these data science techniques are incredibly capable of producing calibrated probabilities and in a sense, outperforming things like Bayesian networks. And there are good reasons why they are. And so I would argue that some amount of the learning needs to go on at that level, recognizing that everybody's going to want to get under the hood and start coding in R or Python or something like that.
Thanks, Dennis. Stephen.
I'd recommend that the decision analysts learn what are the basic approaches that data scientists use. And there's two rough classifications. There's the human supervised things where you can see what's going into it, like a linear regression. And then there's this deep learning stuff where we really don't even know how the thing is coming up with its own recommendation. So decision analysts know what's wrong with regressions. Things aren't linear, they're not linear additive. We've had long conversations about that, but at least you know what the variables are so you can understand them. When it comes to the deep learning stuff, really no one knows what's going on. And so one of the new themes that's coming up is to try to blend the two. And again, coming from a financial background, there's known things like momentum or value or volatility that have names that humans can relate to. You can put those in. The problem is when you've got all your structured data that you understand that explains about 15% of what's going on, what's the other 85%? Well, the machines can start hacking away at that, but rather than just saying the answer is this, buy Tesla or whatever, it'd be good to know, here's all the stuff that you understand, and then here are some things that you don't understand, and maybe we can start to classify those and start to give those names. And so if you blend the two of those, you're going to get a lot more credibility, and you can also see where something completely mysterious has overruled everything you already know about, and maybe wonder, what is that mysterious thing that has just overruled everything I already know?
Thanks, Stephen. David.
So to answer one part of your question that hasn't been addressed yet was the resources. Mm-hmm. So we're blessed that there are tons of free resources out there in the data science world. Mm-hmm. There are a number of very active online communities where people will post questions, other people will post answers, and in some cases you'll get debate, in other cases it'll fizzle out. But and we've got tons of open source software tools that are being created They're posted to GitHub, they're forked, other people then create variations on them. There'll be debate about what should become mainstream, and in some cases you'll have the forks will splinter off and become another side community that rejected the mainstream tool. But it's a thriving world of free tools and resources that are available to us. So it's really easy to immerse yourself in. It just takes time. One thing, so I'm a big believer in transparency, and I hate when I look at a neural network model and I can't understand how it works. That said, to some degree, there's a little bit of analytic laziness involved here, because any one individual layer within the models you could pick apart, and you could, if you're talking about a convolutional neural net, you could visualize what that response is that's passing through it. Now, I'm sure that the researchers at the companies that are deploying these things spend some time doing that, but your average person, or even your average data scientist who's using these doesn't do that, or if they do it for particular layers that they care about. But when you're dealing with a 100-layer deep neural network, you're not going to spend your time doing that on every layer. But I say that just it's as much that the models are opaque inherently as it is that they're just really big, deep models, and we don't spend the time to go and pick them apart at that level of detail.
Okay. All right, thanks, Dave. Isaac.
Yeah, so I think I would agree with what everybody has said so far. There's some philosophical questions about what data science purports to do that everybody should be comfortable with. But I imagine in this community, in this room, everybody's fairly quantitative. So most of the techniques that we're using in data science, you all would be familiar with. Most of you learned the exact techniques while you were in school. I would go on the other end of the extreme that may not be as popular of an answer, and I really think that you need to pick up some of the tool skill sets. You're going to need to know how to integrate with R if you're not already. You're going to need to know how to integrate with Python and its related data science libraries if you don't already. If your livelihood is to deploy solutions that decision makers consume, and you're competing against the data scientist that purports to do the same thing, you've got to know what that toolkit is that they're using, especially if you show up and there's already a solution that's deployed. How are you going to integrate with it? How are you going to make sure that you adjust it so that it uses the correct types of decision logic and philosophy? And this question about general picking up of toolkits is something that's near and dear to my heart. So when I was at Army Cyber Command, we went through this huge effort to put together this massive data lake. And then once the data was there, we all looked at each other and we were like, all right, so what do we do now? Like, what questions do we answer, and how do we go about it? And it turned out like that next step, like once you have data, it isn't obvious how you deploy solutions out to decision makers. But as that's slowly been solved, it's been solved using these scripting languages. So from a philosophical perspective, I assume everybody could pick up linear regression really quickly. You need to understand deep learning. If you're informing decisions and you don't know what deep learning is, there's some very straightforward resources. I would recommend Andrew Ng's deeplearning.ai course. He actually has an AI course specifically for executives, if that's more your flavor, and you could finish it in a couple of days. And then I would recommend picking one of the two scripting languages. I think this community would be closer to R, so I would recommend that you pick up and learn R in a week or two, and get the foundations there. There's a fantastic platform where you can do that. As a matter of fact, we used the startups platform that's goal is exactly that, Matrix DS, and the workshop a couple of days ago. So if you're curious about how to get started and writing your first few lines of code, grab me afterwards, and I'll be more than happy to point you to a place where you can get going right away.
All right, thanks. So we've gotten a bunch of questions that have been entered. Let me stand up so everybody can see me. That have been entered into the system. I'm going to go through a few of those now with our panelists. This is your chance, if there's something that you're burning to ask, enter it now, or I won't see it. And I probably can't get through all of these, but let's start with the one that's been upvoted the most. Okay, and I'm gonna send this out to the group, and whoever feels moved can answer it first. Decision quality with decision analysis needs relevant, reliable information. Okay? So how do DAs go about leveraging data science in determining relevance in the DA context?
If it's a piece of an overall thing, like, here's a bubble in your influence diagram, how well does the historical data that you have match the application you want to use it on? If it matches really well, great, have at it. Have the little machine train up a little model.
We determine at the early on in the cycle whether some uncertainty, how much some uncertainty is worth, and if it's worth enough, do we then go out, deploy sensors or whatever we have to do in order to gather data that can provide us insight into that community? A lot, but not all, of the data science current fascination is on doing more with the data that you have. We've got all this data that you're just sitting on top of. What could we learn from it? Well, if your data are relevant to your problem at hand, then great, have at it. And if your data aren't, but if your problem at hand is worth money to you, then you need to go out and start gathering the data that you're missing. So going through the value of information exercise that we're familiar with is huge here.
Great.
Yeah, one
Dennis.
thing I'd like to add is in decision analysis, we're really interested in making probabilistic statements about what's going to happen in the future. And we all know our stockbrokers advise us that we can't assume that based on past activity, the future is going to behave the same way. And so we're used to using experts. I think one benefit of data science that fits in based on this question is we're now able to do a lot of better data analysis to make the experts better understand what's happened in the past and why it might have happened in the past, and whether there are trends that are going to change what might happen in the future. And so I think one thing that we shouldn't overlook is to use data science to improve the quality of our experts and what they understand and so forth.
Thanks. I think we have time for one more question, and this is sort of a long one, but it's very relevant. For many data science applications, for example, what Facebook or Amazon chooses to present to its users, the value function is frightening and addiction. Many tests are against user behavior, keeping our attention. I find this terrifying because purpose is lost. Am I off base? Please comment.
I think Ron Howard would tell you you could have the same problem in decision analysis as well. It's amoral. You can choose to use it for very devious purposes. I would absolutely agree with that, though. That is 100% the case. Every single social network's job is to get you as engaged as possible. And if you don't know how well data science is working, you should take a look at how addicted you are to your to your social media accounts. I think it worked pretty well in that context. That is a fantastic point, though. We think through some of these ethical concerns, and ethics inside of the data science community is very nascent. The fake news algorithms have brought that to the forefront. We have great ways of potentially identifying things, but when we have false positives, sometimes they can have significant outsized ethical impacts that we didn't anticipate.
Thanks. I think, sorry Dave, I think we're out of time. If everyone could give our panelists a round of applause for their time.